Welcome to my channel, dear students and all the viewer. See, here is the problem of our differential equation, that is y triple dash plus y dash equal to tan x. Now I am here solving this problem by the two methods. Number one, the method is here variation parameter, and the other is this differential is called the linear differential equation with the constant coefficient, and it has a two part of solution of this method, and that is the complementary function, and number two is the particular integral. Okay, see, now first we follow the second method, that is the linear differential equation of the constant coefficient here, and it has a two part of the solution. This is the complementary function, and number two here is the particular integral. Okay, now therefore the solution is here. Okay, in the above equation, has two part of solution. Number one, complementary function. Number two, particular integral. Okay, particular integral. Now to find complementary function, let y equal to e to the power mx be the trial solution of, that is, y triple dash plus y dash equal to 0. It can be also written like that, dqy and dx cube plus that is dy dx, and also that is the operator, that is dq plus d in the bracket y is equal to 0. So implies that is mq plus m equal to 0. Take common m here, that is m into m square plus 1 equal to 0. Therefore m equal to 0 and m equal to plus minus I. Okay, therefore ycf, and that is equal to e to the power c1 into e to the power 0 dot x plus c2 within the bracket. Here is, let us assume here is a and this is a b. No, this is, let us assume as a c1 and this is as a b into, and that is c1. No, we can apply that a into a1 into cos of x plus a2 into sin x. Okay, now multiply by this is c1 actually. If we multiply by b, let us assume this is, and c2 and cos x, and b into a2 multiply, then we got the coefficient. Let us assume this is as a c3 and this is sin x. Let, and c2 is equal to b into a1 and c3 is equal to and b into a2. Okay, this is the complementary function. Now I want to use the second part of solution, that is called the particular integral, and that would be here. It is denoted by y suffix pi. Okay, and that is equal to 1 over, with the help of the operator with this, it can be written as 1 over dq plus and d, and this is actually written by dq plus d with y, and this is 1 over this. Okay, this is 1 over this into, in place of that it is tan x, Now take common d here, that is 1 over d, and it is here d square plus 1 into tan x. Okay, now 1 over d, and this is as a partial fraction like d minus I, and here is d plus I, okay, into tan x. Now find only this part. Okay, for only this part it can be written also, okay, this is 1 over d, 1 by d minus I plus, no, this is minus 1 over d plus I into, and tan x. If we simplify, then if we take LCM, then we got this LCM, and on the numerator part here is, that is 2i, this is 2 into I. Okay, now I am calculating only this part. Okay, so it is here 1 by, now 1 by d minus I into, and this is tan x, and it is can be written as, if we take 0, then d actually I. Okay, d actually I, so that's why it can be written as like ix into e to the power, and this is, see, this is the technique, e to the power minus ix into, this is here tan x into dx. Okay, this is tan x into dx. In case of e to the power ix, in case of that, so it can be written as cos x minus sin x into tan x, and this is here dx, and this is equal to multiply by tan x, then we got here e to the power ix here, so integral of tan into cos, so cos are cancelled out, so it is here sin x minus, so this is I into sin square x by cos x, and this is dx. Okay, and this is equal to e to the power ix, so integration of sin x, uh, integration of sin x, no, first write here sin x, okay, minus I into, so this is here 1 minus cos square, and this is here sec x minus cos square, this is minus cos square means only cos x, and this is here dx. If we integrate, and the value of this here, we can write here cos x plus I sin x, so integration of this is minus sin x minus I into integration of sec x, and that is equal to ln mod of sec x plus tan x, and the integration of cos x, it is a sin x, and that is minus sin x. Okay, this is minus sin x. Okay, cos into sin, this is minus sin x into cos x, this is minus sin x into cos x, and I into I, this is real part. Okay, this is a minus I square, so plus, actually this is plus, so sin x into ln mod sec x plus tan x. Okay, plus sin square plus sorry, this is integration of sin x is minus cos x. I am wrongly written here, this is only cos x. Okay, so this is here cos into cos, this is minus cos square. Okay, and sin into sin plus sin square minus sin square. Okay, minus sin square. Then after that, and this is the real part of this complex number, and I into this minus sin x cos x, and this into this take on minus, so this is minus cos of cos into ln mod sec x plus tan x. Okay, okay, this is cos of this minus minus plus 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 sin x and cos x. Okay, similarly we find the value of d plus I into tan x, and that is, if we take is 0, this is minus I, so this is minus ix, and integrating of it is minus, so it would be plus ix and tan x and dx, and this is the technique of solving the partial integral of this solution. So now it is your minus ix, and this is here okay, integral of tan x, and ix means it is your ix means here cos x plus I sin x, and this is here tan x and dx, it is your minus ix. So multiply by tan, then you got here cos cancel, so sin x plus I into this is here sin square x by cos x and dx, and that is equal to cos x minus sin x cos x minus I into sin x. If we integrate, so integration of this is here minus cos x and plus this is 1 minus cos, like that. Okay, we want to get the total solution on within the bracket. This is within the bracket, this is here ln mod sec x plus tan x. Okay, sec x plus tan x minus sin x. Okay, minus sin x. If we multiply this, so real part with real part, that is here cos square x. After that, the imaginary part with imaginary part, I square into I square, this is minus I square plus of this into this, so plus sin x into ln mod sec x plus tan x. Okay, ln mod sec x plus tan x, and I into plus I square plus okay, so minus sin square minus okay minus sin square cos into cos, this is minus cos square, sorry, real part is minus cos square, and this is minus sin square, this is the real part, okay, and the imaginary part is here, this into this is a sin x into cos x, okay, imaginary part, only imaginary part, so this into this, take common I, so minus minus plus, minus minus plus, and cos x with this, cos x ln mod sec x plus tan x, okay, take common I here, so multiply with cos, so minus sin x cos x, minus sin x into cos x, so these two part are cancelled out. Now I want to get the solution of this part, therefore 1 over d minus I minus 1 over d plus I into tan x, and that is equal to doing this minus this. Actually this result, this is here 1, this is 2, doing 1 minus 2, okay, doing 1 minus 2 here. The solution is here cos square sin square, this is minus 1 plus sin x and ln mod sec x plus tan x, okay, plus I into minus cos x ln mod sec x plus tan x, okay, doing minus this whole thing, minus minus plus 1, and this is minus sin x ln mod sec x plus tan x, okay, minus I into cos x and ln mod sec x plus tan x, okay. Now look here, these 1 plus 1 minus 1 are cancelled out, and this is here, these two part also cancel out, just we have left here only the part is here 2i, these two part are same, so this is here minus 2i minus 2i, and the cos x and ln mod sec x plus tan x. Now this is here 1 over 1 by 2 di, 1 by 2 di into 1 minus d minus I, 1 over this is into tan x, so this is equal to 1 over 2 di into minus 2i into cos x ln mod sec x plus tan x, okay, 2i are cancelled, so this is here 1 by d, it means integral, cos of ln mod sec x plus tan x and dx. See, and this is here, the integration of that would be here, this is the integration of that, so this is there actually minus ln mod sec x plus tan x, integration of cos x, this is okay. After that, the differentiation of this is we get here 1 by sec x plus tan x, and the differentiation of sec x, this is sec x into tan x, plus derivative of sec x is sec square x, and the integration of cos x side is sin x and dx, and that is equal to minus sin x ln mod sec x plus tan x. If we simplify, then we got here sec x into okay, this is sec x into this is minus minus plus, so sec x into sin x, this is integral tan x, and so integral of that is ln mod sec x plus c. Okay, this is only log of sec x, not needed to write here. This is ln sec x. Okay, now the required solution, therefore the required solution therefore the required solution is y is equal to YCF plus YPI. YCF is this is C1 plus C2 into cos x, C3 into sin x plus Pi, and the part, this is a particular integral, solution of particular integral, and this is actually y suffix Pi. Okay, no, this is not, therefore this is here y suffix Pi is this is okay, this is minus sin x ln mod sec x plus tan x plus ln sec x. Okay, so this is our required solution for this method. Okay, this is the linear differential equation of constant coefficient, and it is a part of solution, that is the complementary function, and second is the particular integral, and this is the very important part of the particular integral is this is the very important calculation to see carefully. Now I am solving this problem again with the help of the variation parameter. See, so second method, so this is your CF solution. Okay, particular integral, sorry, complementary function. Let the particular integral, and that is YPI, and that is C1 with respect to now we want to find the quotient of C1, C2, C3. Okay, C3, we let us assume these three constant as a variation parameter, that is V1 and plus V2 into cos x and plus v3 into sin x. Now this is y suffix pi and this is as a y. If we differentiate ypi, okay, this is yp. If we differentiate, that is y dash p, therefore y dash p is equal to, this is the derivative of this is, so v1 dash plus v2 dash cos x plus v3 dash sin x. This is we want to differentiate with respect to x with u into v, with the help of u into v. So first the derivative of v2 into cos x, and derivative of cos x is minus sin x. Here is minus sin x into v2, and the derivative of cos x sin x is cos x. So cos x into and v3. Okay, so method is here. The first order of this part is actually 0. So this is here. Therefore, so v1 dashed v2 dashed into cos x plus v3 dashed into sin x, and this is actually 0. Then here y dash p is equal to, we have left here only minus sin x and v2 plus cos x and v3. Okay, now again differentiate this equation, that is y double dash p. Okay, again this is minus sin x v2 dash plus cos x v3 dash, and this is minus cos x v2. Okay, minus cos x v2 minus cos x v2 and minus sin x v3. Okay, and same as, and this is let us assume as a 1. As a 1. So again on this part I have actually 0. So therefore minus sin x v2 dash plus cos x v3 dash equal to 0. This is 2. Again differentiate, and that is y suffix p double dash minus cos x and v2 minus sin x and v3. So yp triple dash is equal to minus cos x v2 dash minus sin x v3 dash, derivative of cos is minus minus plus, plus sin x v2 minus cos x v3. Okay, now from the equation number, this is now here y triple dash plus y dash is equal to tan x, y triple dash, and this is minus cos x v2 dash minus sin x v3 dash plus sin x v2 dash minus cos x v3, and plus y dash. Y dash is here, Okay, y sub p particular integral. So y dash p here is okay, and this is actually 0, so we have left only minus sin x v2 plus cos x v3. Okay, this is, and it is given that equal to tan x. Now see, okay, now see here is these two polar cancel out, so we have left only this equation, that is we get here minus cos x v2 dash minus sin x v3 dash, and that is equal to tan x. Okay, so therefore the equation is here 1, and this is here 2, and this is here 3. Okay, now solving this 3 equation by the method of Cramer's rule. So the number 1 is here v1 dash plus v2 dash into cos x plus v3 dash into sin x equal to 0. 0 into v1 dash for the second equation, so we can write here 0 into v1 dash minus sin x v2 dash plus cos x v3 dash equal to 0. 0 into v1 dash, and this is a third equation, minus cos x v2 dash minus sin x v3 dash equal to tan x. Okay, this is the 3 equation. Now check the equation. Here is v dash v2 dash cos x v3 dash sin x, and the second is here 0 into v1 dash minus sin x into v2 dash and cos x into v3 dash, and the third is here 0 into v1 dash minus cos x v2 dash minus sin x v3 dash equal to tan x. Okay, solving equation this by the method of Cramer's rule. So it would be here v1 over something, okay, and v2 over something, so v3 over something, and this is 1 by something. Now see, for v1 coefficient, look here, in that we use the coefficient as 0, 0. On the right hand side, this is tan x. Okay, and the coefficient of v2 here is cos x minus sin x and cos x minus. And the coefficient of third row is here sin x cos x minus sin x, v2 over, and this is in case of v2, the coefficient of v1 is unchanged here 1, 0, 0, and the v2 coefficient here is cos x minus sin x, and cos x, in place of that we put here 0, 0 and tan x, and the coefficient of v3 here is sin x, and this is here cos x, and this is here minus sin x, v3 over v3, this is 1, 0, 0, v2 coefficient is here cos x minus sin x and minus cos x, In place of v3 we have to put the only the value on the right hand side, that is the third column. We see 0 0 tan x, 0 0 and tan x, and this is one of our the coefficient of v1 v2 v3, that is 1 0 0, and this is our cos x minus sin x minus cos x, another is there sin x by okay no not by and this is our cos x, this is our minus sin x. Okay, so from this is implies that v1 over, if we expand, this is tan x, and if we multiply with this sin square plus cos square plus sin square, this is only tan x. Okay, this is here only got tan x, and v2 over, if we simplify, if we take 1, so sin x minus sin x. Okay, this is here minus sin x minus sin x, and this is v3 over, if we take 1, this is here only, this is 0, so minus sin x, so minus sin square by minus sin square by cos x. See again, okay, minus sin square by cos x. And now if we solve this, plus sin square minus plus cos square, this is 1 over 1, so v1 is equal to tan x, v1, oh I am wrongly written, this is dashed, so v1 equal to tan x, v2 dash equal to minus sin x, and v3 dash equal to minus sin square x by cos x. Okay, as v1 and dash equal to here, so tan x, so therefore the v1 equal to integral of tan x, and this is ln sec x. Okay, now v2 is equal to minus integral of sin x dx, and this is only cos x. Okay, and the v3, this is minus integral of 1 minus, and this is actually sec x minus okay cos x, and dx minus ln mod sec x plus tan x, and minus minus plus, and this is sin x. Okay, this is a v1 v2 v3 result. Okay, now, and this is a ypi, therefore the y suffix pi is equal to v1 v2 into cos x, v3 into sin x. Okay, so now put here v1, the v1 is here cos x, v2 here is, okay, no, v1 is here ln sec x, v2 means here this is cos x into, v2 means cos x into cos x. Okay, v3, this is here v3 means the result of minus ln mod sec x plus tan x plus sin x into sin x. Okay, rewrite the equation, they rewrite the ypi, that is ln sec x, and this is a cos square x minus, and this is sin square x minus sin x ln mod sec x plus tan x. Okay, therefore the required solution, therefore the required solution is y is equal to y CF plus ypi. That is, CF is here, this is C1 plus C2 cos x plus C3 sin x, okay, plus the solution of pi, this is ln sec x plus sin square plus cos square is there 1 minus 1 minus sin x ln mod sec x plus tan x. Okay, see, these and these also are constant. We can rewrite again C1 dashed equal to C2 into cos x and C3 into sin x ln sec x minus sin x into ln mod sec x plus tan x, and this is your answer. So match with this solution. This is actually constant, these also are constant, so both not are different, these are same. Okay, so see, this solution are same. Okay, this is the two method of solving this one. This is a very important problem for the different type of exam like BTech, BSc and honors. Okay, see carefully, this is most interesting problem. Thank you for watching my video. Okay.